Welcome back to part 2. Now that we've got our Swagger doc file, we can do something useful with it. We could of course just publish that to the world, but we are actually going to use it to create an SDK. In order to create the SDK, we need to install Node.js first because we're going to use something called AutoRest. AutoRest is a tool produced by the Azure team, and it will convert our Swagger doc into our C# source code for our SDK. It can actually also produce source code for Ruby and TypeScript and Java and a few other languages. So now we have Node.js. We'll run npm install -g for global and then AutoRest. This will download the AutoRest tool and install all the dependencies for us. Now we use -g, so it's available for all users. We could just install it for our current user if you want, but I've decided to install it for all users. No point each user having to install it on a machine. Now that that's installed, we can head over to our application and we'll start our application running. This is so that we've got a Swagger file to actually grab. Now we could save the Swagger file, but instead what we're going to do is generate it straight off our web server. Let's just check that that Swagger file is loading up here. There we go. So we can grab that link out of the top there in that bar. And we will head over to our project and make a new folder called CodePersuit service.sdk. Head into that folder and then we will run AutoRest with the input set to the web server's address, and the code generation type will be C#, and then the namespace will be CodePersuit.service.sdk. Now by default it will output to its current folder. When we set up a script later we will set the folder. What it will actually do is put it into a folder called generated, which is useful if you need to override some things. All the classes are set to partials, and we'll show later on when we get to the service discovery section in the next tutorial why you might want to do that. Now we'll make a project file for it. We'll make it as netstandard 1.3. So we'll jump across here, we'll add the project to our solution. There we go. And it won't build yet. We'll delete that class 1. It won't actually build yet because, as it said on the command line before, there's actually a package we need to include, which is the Microsoft REST package. So we'll search for that on NuGet, which is Microsoft.rest. There we go, .client runtime. Now, we've made a little mistake here. As you can see down there, the minimum version it supports is netstandard 1.4. So let's just go ahead and edit that CS_proj file. Change it to netstandard 1.4 instead of 1.3. Save that. Close. And now we should be able to install. Once we've installed that, we should be able to see our code and we should be able to build it. Finally, we're going to add a folder called test, and we're going to add a test project which will basically be the start of our integration tests. This will use the SDK to test our current project in our interface. We'll be running a full web server inside our integration test. Now you could actually run the test host, which doesn't require a port, it doesn't require using the actual network, but I prefer to use the full Kestrel stack. It's light enough and it's fast enough that you can just start up a web server and shut it down. As long as you don't have too much in the startup, you don't preload, pre-cache a bunch of stuff, which we definitely haven't so far. If you do, you can start looking at using fake services and things like that, but ideally when it comes to testing, if you can test as close to what's going to run in prod, the better. So next up, we'll make a method called canLoadUser, and we'll just create a host As I said before, we're going to use the full web host builder, and we will add using Kestrel to that. Sometimes if I have problems with Visual Studio not connecting the dots on new projects, I tend to just do a build, even if the build doesn't complete properly like it hasn't here, and just reload the project. What you find is it tends to then pick up things. Sometimes it just it seems flaky for me. I don't know what others' experience of VS 2017 has been. Anyway, back to our project. Alright, so we do the typical use URLs. Now, later on, especially as we start building up our tests, and when we show you some tricks in the service discovery, we will dynamically allocate ports here. But for now, we're just going to stick in one specific port, use Kestrel, build, and then host.start, because we don't want to block on this, otherwise we won't get to the rest of our test. Now we'll use the SDK, so CodePersuit service.sdk, and it's the CodePersuit API is the core class. And it's generated from the description that we put in our Swagger document. Finally, we'll give it a URL, and the URL is going to be the same one that we put in the use URLs. We should probably break this out as a variable. As I said, we'll come back and we'll clean these up a little more later on. And then finally, we'll put up here the extension methods. So we need to put in the namespace of our SDK, as it comes with a number of extension methods that give us a much tidier API. Now, if you look at these API methods, these have been auto-generated from the names and from the inputs to the methods. And as you can see, they're a little bit ugly. We've also got duplicates of async and non-async versions. So we will be cleaning those up in the next part of this tutorial, so don't worry about that for now. Right now, let's just check to see if things are working. So we'll make this an async test, which is perfectly supported by XUnit. And then we're going to assert that the user ID is equal to 1, because it should be our first user, and because we have a fixed database that is rebuilt every time, we've got no problem matching that, and that the name is the name that we searched for. Obviously, we should add more tests to check that we can get the second user out, etc. But for now, it's just a simple test. And we'll make sure we start our SQL Server Docker image. When we set up our build and CI testing later on, we'll make sure that that's all part of running our tests, is to start the Docker image, kill any existing ones, etc. Our host is disposable, so we'll just wrap a using around here to make sure we don't leave any latent servers up during a test run. And we'll chuck our var back up in there. Excellent. Open up our Test Explorer window, get it all building. There it is there. And we'll run it for the first time. And what we will see from running it is a failure. What we've done is forgot to put the startup class in here, so it's actually a failure of the test, not a failure of our code. So let's try that again once we have our startup class, and we'll run our test again. Simplify that, and failure again. Internal server error. Okay, we're gonna have to debug. This is, I guess, why we add tests, and see what's going on here. So let's start the test up in debug mode, and we seem to have hit this correctly. Let's run from here. Okay, it looks like we've got our Dapper code incorrect. Always useful to write tests, folks. So we'll just fix that. That was a small typo, and let's We'll run that. We'll run it in debug again, and let's see what happens. And this time we pass our test. Excellent, we've got a green. So I'm going to go ahead and add a few more tests, but we don't need to do that on camera. And we will see you for the next tutorial where we'll go through cleaning up our API a bit. I would have added a couple more tests by then, and just see how we can make things, give things a little bit more information via our Swagger doc and make our API look a lot nicer. Thanks for watching. See you next time.